On the first page of the Unit 3 review, we need to graph and label each equation or inequality. So this page should be perfect. And the reason why it should be perfect is because you should have checked every single one of these on your graphing calculator. Every one of them. And on the test, you're going to do the same exact thing. Of course, there's some questions that we need to show work on. We'll talk about those in just a moment because that is E and F on this front page. But remember, when you graph equations, your calculator is defaulting to y equals mode. So if you have y equals something, you don't need to change the f1 of x to anything because f1 of x is really your y. So for example, b. b is written in that form. Let's do that one first. So we want to do x divided by 3. And you can hit enter just to make sure that your line is pointing in the right direction, that your slope is correct, and if it's an inequality, that the line is either solid or dashed. If we look at, so I'll add a page, add a new graph. If we look at A, notice how it's an inequality. So immediately I know that I need to get into relation mode by pressing delete, go to relation, and then I can type it in exactly how I would like to see it. So y is less than or equal to 3/2 x minus 7. And then you hit enter, and it graphs the inequality. You can also hover your mouse so that it looks like the pointing finger, and it will show you even more clearly that this indeed is a solid line and we're shading below. You can do the same thing for C, D, E, and F, and most of them you'll probably have to change to relation mode. Like D you'll have to, E you will, and F you will. Because E and F are not written in slope-intercept form, that's why we have them written in slope-intercept form. So for example, in F, we moved the 2x over to the other side to become minus 2x, and then divided everything by 2, so that way our y was alone, y equals mx plus b. You could have also have written this as y is equal to negative x plus 5. Same thing happened over here in E. It was much simpler. All we needed to do was move the negative 3 to the other side to get y is greater than negative 2x plus 3. I would encourage all of you to graph these if you haven't already done so, because that will help you with practice for the test. Take a minute right now. You might need to pause the video, and I color-coded everything for you. So this question, without a doubt, you should have work on it. And if for some reason you don't have all of this wonderful math off to the side, you need to write it down now. And you probably got these questions wrong, because if you don't show your work and show what the words look like in the algebra, it's going to be even harder for you to make the connection to the graph. Just to clarify, we are graphing each of these lines in slope-intercept form, so you plot the y-intercept in all of the equations. This one would be 0, my red equation, and then you graph the slope, so the rise over the run, and I showed that off to the side in each one. Anytime you are finding slope, you should always make a table, with the exception of C, and we'll talk about that in just a moment. But for A and B, you can see that I took the point 1, 5 and actually put it in the table. I input 1, I got out 5. I input negative 3, I got out negative 4. I figured out how my y's changed, I figured out how my x's changed, and change in y over change in x gave me a positive 9/4. It's okay to look at that in a decimal as well. And if you look at 9/4 as a decimal, you end up getting 2.25. In B, they gave you a table. It had a beautiful pattern. The x's were going up by 3s as the y's were going up by 2s. Change in y over change in x would give you 2/3, or 0.6 repeating. I always find that leaving your slope as a fraction is typically the best. C, you could have, oh, I think we're missing a little piece here. It told you the domain underneath here, which I don't really care too much about because a linear function, it doesn't matter what the domain is, because with a line, everything, or the slope, is consistent across the whole graph. And my line is already written in y equals mx plus b form, so my m is the -1 that's in front of my x, so the slope is -1. You could also graph it and see that you had a nice line that was increasing, or sorry, decreasing at a rate of -1 down and then 1 to the right. For number 4, I should see a table and I should see now, before, next rules for every single piece, 1, 2, 3, and 4. So I first set up my table. He opens the account, so initially there's my 0, there's my y-intercept of 500, and every single week he is taking out $20. So I modeled the first 3 weeks, including the initial amount. You could have made your table longer, but I can already see my pattern as I'm taking away 20. The reason why I'm not really focusing too much on my starting point is because all answer choices 1, 2, 3, and 4 say that we start at 500. So what that means is, in number 1, why it's correct, the now is equal to the before minus 20. So anytime I look at the now, I look before, take away 20, and I get the value I'm supposed to. I could do that for any point in my table, and you would still end up getting the same rule that would work. 2 of them that really don't make sense at all would be 3 and 4, because you can't say that the now is the same thing as a now minus 20 or plus 20. So those are totally out. Number 2, you just have to be a little careful because it's very similar to 1, but if I want to get to the now, I can't look at the next and take away 20, because if I take away 20 from 440, I actually get 420, and I'm supposed to get 460. So if you don't have work written down for number 4, write it down now. Pause the video and do that. Number 5, we should make a table. And I looked at all of my answer choices first to see that these were not written in a recursive pattern. They were actually written in linear form. So it's a function form, y equals mx plus b. So in my table, I needed to work backwards to get my y-intercept. So I wrote out the terms. I noticed that I was increasing by 4 in my y values while my x values, or my n values, were increasing by 1. Working backwards, I would get the 0.08, which is my y-intercept. And immediately, I can circle answer choice 2, but just to be thorough, we added 4 going down the table and added 1 going down the table, so my slope would be 4 over 1, which is 4, also the reason why the slope is true. If you ever want to check yourself, type in your calculator 4x plus 8 and graph it and look at the table of values and make sure it matches up here. To look at the table, hit Control T, and as you can see, I have the 0.08, 112, 216, 320, and so on and so forth. I could use this table to help me find term 15 if I wanted to. I could also use my equation and substitute. In number 6, we're looking for something that does not represent a line, a linear function. Obviously 2 is a line. Number 3 is in y equals mx plus b. So is number 4. So just by process of elimination, we could have selected 1, but the reason why it is not linear is because my slope is not constant. If I wanted it to be constant, my x's would have all gone up by 2's and my y's would have all gone down by either -2 or -4. Here's a discrepancy. In question number 7, I hope that you made a table to model the situation, that you started at $60, and for every additional megabyte, so that's what my D, or in my table I have it written as X, my Y is really C, so every additional megabyte was 5 cents more. So my slope is 5 cents. That would be multiplied by the number of megabytes, and we started out my y-intercept at 60. You could also graph this on your calculator to make sure that the table matches up. I would strongly encourage you to do that on a test. Number 8 was pretty straightforward. They wanted you to identify what the constant meant in this equation, this linear equation, and the constant of 125 is the value that never changes, or in this case, the startup cost. In question number 9, you should have divided this up into 2 sections in order to find the y-intercept. It's when x is equal to 0. To find the x-intercept, it's when y equals 0. So you just substitute them in to the same equation and solve for the variable. So 9 times 0 is 0. That disappears. We end up getting y is equal to 9 and x is equal to 3. You can see that it's modeled on the graph here. And for B, it wanted you to write it in slope-intercept form. So this is just sorting, getting y alone. You could have had y is equal to 9 minus 3x. You start at 9, you go down 3 to the right 1, or you could have written it what I have here in blue. One thing that you should always do is after you've sorted or gotten y alone, you should immediately jump to your calculator and make sure that what you did was right. So let's first type in our y equals mx plus b form. So 3x plus 9, and we're going to graph it. You might want to change this by double-clicking it to, it looks like our graph had 10. It gives you just a little bit better picture. And if I want to add a new function, but in this case I have to write it as a relation because x is not alone, let's graph 9x plus 3y equals 27. Oops, what did I do wrong? 9x plus 3y equals 27, and the two lines should line up right on top of each other because they should be the same when you rewrite. And number 10, when you find the equation of a line, we should be looking at y equals mx plus b form whenever possible. We have a beautiful y-intercept at 1 and a slope of down 3 to the right 1. Negative 3 over 1, and you put them together to get y equals negative 3x plus 1. Number 11, we should be creating a linear equation, again in y equals mx plus b form. $50 is the constant, or the y-intercept, and we're going to be charged, or Jenny will be charged 10 cents every minute x. Remember to look for clues in the question. They told you what x was, so you will use it. Number 12 is very similar to what we did up in question 9, where you wanted to make sure that when you rewrote it in a way that you ended up with the same equation. So to check it, you're going to graph it just like what we did over here. Graph this, and you could graph every single one of these. If this ever comes up on a Regents exam or a test, you technically don't have to show work, but of course we are going to be really good math students. And we're going to just take our equation and manipulate it to make it look like one of our answer choices. In this case, we had to divide every single term, so 3x minus 6y and 12, all by 3, to show that these two are the same. But if you graph 2 and 3x minus 6y equals 12, so x minus 2y equals 4 is what I mean by 2. These two equations will look exactly the same, where if you graph 1, 3, and 4 with the 3x minus 6y equals 12, they would all look different. In number 13, it says you have to write an equation of a line that has the same y-intercept as this line. Well, the first thing that we should do is figure out what that y-intercept is. And in order to do that, you can either graph it and look on the graph, or to show it algebraically, because that's what answers will be accepted on short answers, get y alone, get it in y equals mx plus b form. Very similar to what we did in number 12. In this case, we can see our constant, our y-intercept, our starting, where we begin, is 5, and it doesn't matter what your slope is. So that 2 could have been 500. It just says write an equation of a line that has the same y-intercept. It said nothing about the slope. So you just need to make sure that your equation looks like y equals something times x plus 5, and that 2 could be anything. I'm hoping that everyone in question 14 first created a table of values. Here I have it written up above. They didn't tell us the initial value, but I needed to do that because I have to find my y-intercept. So that's where the plus 1 came from, and my slope was adding 3 checkers every single step. So 3x plus 1. Part B, if we want to find the 105th step, we put in 105 into our x, since x is the number of steps, to find that there's 316 checkers. And C, this is working backwards. It said, what step would it be if Kendra uses 97 checkers? Well, that's our y, or in this case, our m of x. And then it's a simple two-step equation. Subtract 1 from both sides, divide by 3 to find out that it was step 32. Question 15, they gave you a table, and number 1, or part 1, they wanted you to find the average rate of change, which is really the slope. So negative 400 divided by 4 is negative 100. And then it said to write an equation. Well, in order to find our equation, we need the slope, which we already have over here, and we need the y-intercept, which unfortunately was not given to us in the table, but we know how to work backwards. So instead of adding 4 downwards, we can subtract 4 going backwards to get 0, 5,000. And this y here actually should be written as s of x. Moving on to question number 16, they didn't tell us anything about variables. Your variables might be C and L, or they might be X and Y, but either way, this is what your equation should look like. Remember, we talk about being consistent with our units, so money, money, money. If you just had C plus L, that would be the number of cookies, and L would be the number of lunches, and that would be that wouldn't be consistent. So lunches, cookies, money. We have to put everything in terms of money. So in part B, Scott said that there might have been 100 cookies and 220 lunches sold. All we need to do here is substitute. And when we do that, we find that this is not possible. 570 did not equal the 585, so Scott was wrong. In 17, I hope that all of you made a table. Everything that they gave us, I put in purple. So they told us the third term was 12 and the fifth term was 16. And since it was arithmetic, we know that we are adding or subtracting. So how could I go from 12 to 16? Well, I had a 4 in between there, so I can't just add 4. That's not what is being added as I go down the table. I actually am adding 2. So there was a skipping stone in between, so 12, 14, 16. Let's work backwards in the table. And again, why did I get that y-intercept? Well, look at all of my equations over here. They're in y equals mx plus b form. I already know my slope is 2 over 1 because look, we're going down, or we're adding 2 in the y's as we're adding 1 in the x's, so 2 over 1 is 2. 1 and 2 would be out because of that. Look at the slope in front of my n's, not 2. So we work backwards in the table by subtracting 2 to get 0, 6. There's my y-intercept. To check your work, graph it. 2x plus 6 is what you would type in over here in the function. Control T and make sure that your table matches up to the table over on the calculator. Number 18, there were a couple words missing. Marnie wants to go to Carnival X and Carnival Y repeatedly over the course of a week because she just loves carnivals. So number 1, it specifically says, or part 1, it says to write in inequality. So because of this, I know that there should not be an equal sign in the problem. Whenever it says equation or inequality, remember, use the clues that the problem says to make sure that what you're writing down is correct and is consistent. Use the clues. She has a maximum of $48. That means all of this over here can't be any bigger than 48. That's why we're going to use a less than or equal to symbol. $6 for Carnival X and $4 for Carnival Y. Money, money, money. We're in the clear. Some of you might say, hey, can't I just graph this right now on my calculator? And the answer is, of course. I would graph it and make sure that when you solve for Y and show your work on when you're solving this, that it matches up to what you have found on your calculator. So make sure that this inequality and this inequality are exactly the same. So what did we do to get from here to here? Well, let's talk about that. We moved the 6x over to become minus 6x, divided everything by 4, and this is the inequality that we ended up with. So we started at 12, went down 3 to the right 2, went down 3 to the right 2, and so on and so forth. It fit nicely by just counting by ones. I know that we are going to have a solid line because it's less than or equal to, and we're shading below because it's a less than symbol. So part 3 wants you to determine a combination of an answer. So I gave you one example. It could really be any points that's in the shaded area or on the line because it's solid. If this had been a dashed line, then we could not pick any one of those points. Last but not least, here's question 19. So we had to use the equation 2x plus y equals 4 and pick whether or not A, B, C, or D were true or false. In A, C, and D, if you wrote your equation in y equals mx plus b form, it could be really helpful. So you start with the original and rewrite in y equals mx plus b form. B was a little bit different. Substitution was awesome to use for this. So take a minute, look back in your packet, and make sure that you have work on all of your questions.